Hello Engineering Club members, my name is Connor Solorzano and I'm your club vice president and also project leader for this semester. So last Friday our club had a meeting and we started the construction of a line following robot using Arduino. So this video is for those of you who perhaps weren't able to make it to the meeting, or were able to make it to the meeting but perhaps missed some of the information on Arduino and want to know a little bit more about how the wiring works, how the programming works, and just know a little bit more in general about how it's used. So to start things off, what exactly is an Arduino? An Arduino is this little computer here, and it can do all sorts of different things. If you have any kind of project, if you're building a project that uses electronics of any kind of sensor, any kind of push button or motor, you're most likely going to need an Arduino, like this one, in order to program everything and to serve as the core of your machine. So far, I've done quite a few projects that require an Arduino, such as the braiding machine, my LED hexagons, and also this automatic water turret that I'm currently working on. The main thing all three of these projects have in common is that they all use an Arduino. So there are a lot of different types of Arduino. The basic Arduino is the Arduino Uno, and it's a fairly large chip like this. And there's a smaller version of it called the Arduino Nano. And they do essentially the same thing. The only difference is that this Arduino Uno has a little bit of a more powerful computer, so it's able to store a few more variables, and also you can plug more peripherals into it. So it has more pins in order to control more things. And the Arduino Nano has fewer pins, but it's a lot smaller than the Arduino Uno, so it can of course fit into a smaller area. And there are also all sorts of other types of Arduinos. There's the Arduino Mega, which is a very large chip that can power all sorts of different devices. There are Arduinos that can be remotely programmed over Wi-Fi. There are Arduino Micros, which can fit into a tiny little area, such as a watch. And there's even the Arduino LilyPad, which is a wearable Arduino that can be sewn into clothing. So for most projects, the main Arduinos that you're going to use are either an Arduino Uno or an Arduino Nano. Now usually what I do is I will program a project on an Arduino Uno, and then once all the programming is complete and the project is ready to go, I will switch over to an Arduino Nano and place all of the permanent connections onto the Arduino Nano. And the reason for this, it may be a little bit obvious that the Arduino Uno is quite a bit more expensive. So an Arduino Uno is around $24, and an Arduino Nano, I get these for around $350. So Arduinos are powered using USB, so you'll just plug a USB cable into the Arduino, and usually the other end you'll plug it into a computer in order to program the Arduino. But once the program is loaded onto the Arduino, then you can plug it into any power source. I usually use a little battery pack like this that has 3 AA batteries inside, and plug it in, and if you turn it on, as you can see, the Arduino now has power. And there are all sorts of power sources you can use for an Arduino. You can plug it into essentially any kind of USB port that you would ordinarily plug a phone into, or any kind of small device. So sometimes I will even use a phone portable charger in order to power my Arduino, if I don't have a battery pack like this available. And as you can see, it's the same for the Arduino Uno here. Any kind of 5-volt power source is going to be enough to fully power the Arduino. Once your Arduino is powered, there are all sorts of peripherals and appliances that can be plugged into it. Some examples include this distance sensor that can detect how far away it is from an object at any point in time using ultrasound. This is a motion detector. It can detect when any object and its detection radius moves at all. This is an infrared sensor. It can sense the shade of certain colors, whether a color is bright or dark, essentially. And an Arduino can also power small 5-volt motors, like these. If you need to use a stronger motor than just 5 volts, like this larger 12-volt motor right here that puts out more power or perhaps spins even faster, then you are going to need what's called a motor shield, or a motor controller. So what you would do with this is you would plug your motor shield into the Arduino, and then also plug a 12-volt power source into a different socket of the motor shield, and that is going to supply your 12-volt motor with the correct voltage without completely frying your Arduino. Now, the nice part about Arduino is that you don't have to do any soldering when you connect wires together. These wires are pin wires, so they will go directly into the pin on your Arduino, and the other side can also be directly placed into the pin on the peripheral that you want to use. And of course, if you need to remove that wire for any reason, it's as easy as just pulling it back out again. Now, a lot of the time, even very simple Arduino circuits end up looking like huge, very complicated messes. But when you understand that that gigantic mess of wires is really just a whole bunch of single pins plugged into the Arduino on one end and into a peripheral on the other end, it's really not all that complex. Now, all of the pins on the Arduino are going to be used for different things. On one side you have the A pins, that means your analog input or output, and on the other side you have your digital pins, the digital input and output. So most of the pins on an Arduino are input/output pins. That means they're either going to take in an electric input signal or output an electric input signal to a peripheral. You also need to attach all of your peripherals to the 5-volt side and the ground side in order to power it. So the input-output pins don't actually power your peripheral. They're only sending signals or receiving signals. The actual power that goes to the peripheral is going to come from the 5-volt and ground only. There are also a few other types of pins that you'll see on here, and these ones are the advanced pins. For most projects, I'd say about 90% of projects or more, you're never going to use any of these advanced pins. If you are curious about what any of these advanced pins do, feel free to ask in the Discord. But for the purposes of this video, I'm not going to cover what the more advanced pins do. For the most part, we're just going to be focusing on the 5-volt pin, the ground pin, and also the input and output pins. Whether you plug a peripheral into a digital or an analog pin is just going to depend on what peripheral you're using and how exactly it works. Usually when you buy a peripheral, the manufacturer will tell you whether it's analog or digital. Now, a lot of the input-output pins are binary pins. So that means they're only going to be able to input or output an on signal or an off signal. Now, there are also PWM pins on here that are marked by a little line, and those ones can output a signal from 0 to 255. And those are going to output a signal strength from 0 to 255. So if you need an output that is not quite full, but also not quite off, then you are going to need to plug it into a PWM pin. So what exactly would that be used for? Well, let's take a motor, for example. If you plug a motor into a non-PWM pin, one of the ordinary on or off pins, then the motor is only going to go either max speed or be completely off. If you plug it into a PWM pin, you're going to be able to have it run at a speed from 0 to 255, with 255 being the motor's top speed. So, for example, if you plug it into a PWM pin and send an output of 100, then the motor is going to run at a little bit less than half of its maximum speed. And if you set it up to a very high number, like 230, it's going to spin very, very quickly, although not quite its maximum speed. For now, we're only going to be focusing on wiring for prefabricated peripherals, such as a motor or a sensor. For more advanced projects, you can also start creating your own peripherals, like an on-off button or some kind of LED indicator. I will be showing you guys how those work in a later video. Now, for a lot of projects, you'll be able to find a wiring diagram online that shows you exactly how to plug in each peripheral into the Arduino. This is the wiring diagram that we are currently following for the line following robot. For almost all projects, you are going to be using a breadboard. How a breadboard works is you plug your Arduino into the breadboard, and then you can plug other peripherals also into the breadboard for easy wiring. The breadboard essentially expands the number of peripherals you can plug into your Arduino at once. The main advantage of a breadboard is the power rails on the side. If you plug the 5-volt into the positive power rail of the breadboard, that entire power rail is now powered by 5 volts. So you can plug any peripheral into that 5-volt power rail and any peripheral into the ground power rail, and it's going to fully power it. Whereas if you are only using the Arduino, there's only one 5-volt power pin, so you can really only power one peripheral at a time. And that's going to wrap it up for today's video. Next week, I'm going to be going over Arduino programming and how the peripherals work on the software side. Thank you very much for watching, and feel free to ask me at any time in the Discord if you have any questions. Thank you, and have a great rest of your day.